Where the air at?
Man, I wish I could have some control, sir. Yeah, I know, right? Temperature change right quick. All right, good afternoon, everyone. Hope all is well. Everybody's doing all right. Sorry to apologize to those in the class, but sorry to those who just getting in the Zoom, ran into some traffic, so I'm a few minutes behind, but it's all good. So as I mentioned last time we met, we started 8.1 today. So we'll get into 8.1 and probably knock out 8.3 as well. Not heavy sections, they're not too long. So, and in chapter 8, we only have 3 sections. So it's 8.1, 8.3, 8.4. We're skipping 8.2. We're not held responsible for 8.2. So that same thing should reflect in Math Lab as well. So 8.1 is percent sales tax and discount. And we break down the word percent. It's per cent or per hundred. So the percent sign represents, so it has the value of 1 over 100, or in other words, 0.01 as a decimal. So the first thing we're going to do is look at converting decimals to percent. So we're going to locate the decimal, move decimal places to the right, and then place the percent sign. So we're just moving the decimal 2 places to the right and place the percent sign. So we have a few examples here. 0.25, move the decimal 2 places to the right, that will be 25%. 1.8. So notice we only have one value to the right of the decimal. So we move our decimal 2 places to the right, we need to use a 0 as a placeholder. So that would be 180%. And then with the 7, you know, when you just see a number and you don't see a decimal, they assume you know it's to the right of it. So we move that 2 places to the right and use 2 zeros as placeholders to be 700%. All right, questions, any questions? Of course, if I scroll too fast, let me know. All right, next, percents to decimals. Excuse me. So this time we're moving in the opposite direction, basically a reversal of what we did in the last example. We're going to locate the decimal. Now we're going to move the decimal 2 places to the left and remove the percent sign. So we have 37%. Move the decimal 2 places to the left, that would be 0.37. Over here, I'm just emphasizing that 0.37 and 0.37 are the same thing. So you can use either or and it'll be fine. So for the 2.9%, move your decimal 2 places to the left. Notice we're gonna have to use a placeholder here for that 0.029. And then if we have 0.6%, we have to do the same thing once again. And have 0.006 as a decimal. Any problems? Any problems? Everybody good? All right. Next one, fraction 2%. So we convert the fraction to a decimal by division. So basically it's just divide. And then once you have your decimal, convert that decimal to percent like we just previously talked about. So 3/5 is the same thing as 3 divided by 5. That fraction bar is the same thing as the division sign. 3 divided by 5 is 0.6. Then you move your decimal 2 places to the right, that'll be 60%. All right, do one more like this. 7/8. 7 divided by 8 is 0.875. Move the decimal 2 places to the right, it's 87.5%. All right, next thing in this section is sales tax. So what is the sales tax on a jacket priced at $425 if the sales tax rate is 6%? All right. So we have two formulas here, two equations that will help us to calculate sales tax and sales price. So your sales tax, you want to calculate sales tax. So in other words, if you see a product at the store, see the price on the shelf, when you take it to the register, they're going to apply either state tax, food tax, or something like that. Then you have to pay a little more than what you saw on the shelf. So this is how you calculate that. Take your tax rate multiply it by the price that you see. That will be the tax, the sales tax. And then from there, if you add that to your original price, that will tell you how much you're gonna have to pay. Yes. Yep, that's gonna be discount. We're gonna talk about that in a second. Yep, but is it exactly right? That's gonna be the same process. Mhm. No. So don't forget when it comes to your rate and it's a percent, you want to convert it to a decimal first. That's why I did the 0.06. So 0.06 times 425 is 2550. So that's your sales tax. And then add that to your original price, 2550 plus 425, 450.50 will be how much you have to pay. Okay, scrolling up. Okay. I forgot whether I chose one for this class or not, but I know in math lab, sometimes instead of giving you a word problem like you saw in the last one, they could give you a chart like this, but it's, you have to fill in the chart. So this time we're talking about discounts. So we're talking about finding missing value. So they give us the mark price, which is another way of talking about the original price. Here we have it at 19.20. Then the discount rate. Write down the sales price. All right, so here goes our formulas or equations for discount. You want to calculate your discount amount, like your classmate mentioned, you're going to take the discount rate, multiply it times your original price, and then from there, subtract it from your original price. All right, so let's plug in the pieces. To find the discount amount, we'll do 19.20 times 0.25, which will give us $4.80. And then we'll subtract that 480 from the 19.20. That'll be 14.40. Any questions? Any questions? All right, so last thing out of this section, talk about percent increase and percent decrease. We're gonna calculate both of these the same exact way. First, you'll find your amount of increase by subtracting your values, divide that by the original amount, and then multiply that by 100%. And then you do the same thing for percent decrease, if that's what you're looking for. All right, so find the percent increase in the federal debt from 2005 to 2010. Those values will be given to you. I got these values from the chart that he gave. So we got 7.91 trillion, 2005, and it goes up to 13.53, 2010. So to find the amount of increase, we subtract the values and we get 5.62. Place that over the original amount, which was 7.91. Then we multiply that by 100. So dividing those two numbers gives us 0.7104, multiplied by 100, 71.04. So that's your percent increase. Good. All right, so if they ask us about percent decrease, and let's say it went down from 10.9 to 6.4, you're going to follow the same process, same procedure. You need to find the amount of decrease by subtracting the two values. That's 4.5. Then you divide by the original amount, which was 10.9. Multiply by 100, that'll give you 41.2%. Questions, questions, questions. Scroll up, everybody good. All right, so that's it for 8.1. Get into 8.3. Once again, remember I mentioned that we're skipping 8.2. You guys are not held responsible for 8.2. No, I still holding on to 8.1. So simple interest. So our simple interest formula is I equal to P times R times T, where I is your interest earned, P is going to be the principal or deposit or loan. R is your rate. Don't forget to convert it to decimals before you do your calculation. And T is your time, which is in years. All right. So like I mentioned, T, we need to have in years. So if it's not in years, before you do any calculations, you're going to want to convert it to years. So if we had T being 24 months, we know that's 2 years because we divide that by 12, and we divide it by 12 because there's 12 months in a year. So if that's the case, you want to keep that same thought process, the same energy when it comes to numbers that are not divisible by 12. So if I have 13 months, in order to convert it to years, I put 13 over 12, just like I did this 24. I put it over 12 because I have 12 months in a year. If I have weeks, 37 weeks, I place that 37 over 52. It's 52 weeks in a year. And then if I have days, I will place that over 360 because of banker's rule. So we'll not do 365. We'll do 360 because of what they call banker's rule. I had a couple of explanations that I've seen. One is because they say there's 5 major holidays, so that's where the other 5 days go. And then the other one just said that it's easier calculation for bankers to do 360 instead of 365. So for days, you will use 360 instead of 365. All right, scrolling up. All right. Find simple interest after 2 years on $500 at an interest rate of 12%. So best practice is to extract all of your information first, your given information first. So P is going to be 500. That's the amount of the deposit or the loan. 12% is our rate. So that will convert to 2.12 as a decimal. And then we have 2 years for time. It's in years, so we don't have to worry about converting that. And then from there, use our interest formula, P times R times T. 500 times 0.12 times 2 going to be 120. So $120 will be the amount of interest that will be accumulated after the 2 years. We put $500 in this account at 12% interest rates. All right, any questions on that? All right, next one, a college graduate borrowed $2,400 at a 10% simple interest rate for 8 months to buy a used car. Find the simple interest he paid. All right, take the information out of the problem. P is 2,400, R is 10%, so that'll be 0.1 as a decimal. Now T is 8 months, so I want to rewrite that in terms of years, so that'd be 8 over 12. If you want to reduce it, that'll be 2 over 3. You can use either or in your calculation. It does not matter whether you use 8 over 12 or 2 over 3. If you're using a calculator, it's going to calculate to the right answer anyway. So 2,400 times 0.1 times 2/3 will give you 160. No, everybody good. Now, the next question is a continuation from this problem right here. Find the total amount paid for the loan. So the way we'll do that, total amount is going to be equal to the principal plus your interest, the initial amount that you have plus the interest that has accumulated over the time. So that total amount, the variable that we will use for that moving forward is A. It's also called the future value. And so we'll take P, which is 2,400 plus that 160, our interest, which is 2,560. Okay, so the future value for simple interest. So instead of doing or calculating your future value or the total amount in pieces, there's one formula that will calculate the whole thing. So this doesn't calculate the interest. It calculates the future value. Now you can't separate it and do other calculations, but we're just talking about calculating the future value in the account. That's what this formula is for. This is P times 1 plus RT. Now, if you just want the interest, you use the first formula of I equals to PRT. So this calculates the future value plus that interest, or that principal plus your interest. So you gotta make sure you pay attention to what they're asking of you. If they ask just for the interest, that's what we were doing previously. Now here, we're asking for the future value. So a loan of $1,060 has been, I feel like I left out a word. Anyway, a loan of $1,060 has been at 6.5% for 3 months. Find the loan's future value. I want to leave out the word. That's copy that. Yep, has been made. So a loan of $1,060 has been made at 6.5%. Okay. So first thing we're going to do, extract the information that we need. So we have P, which is 1,060, the rate 6.5%. That'll be 0.065. Then we have time of 3 months. Place it 3 over 12. So you can use the 3/12 or the 1/4 as your value plugging in. Plug into the formula. A is equal to P times 1 plus RT. So that's 1,060 times 1 plus 0.065 times 1/4. And that'll give us the answer 1,077.23. One more, I think we'll be good for today. So you borrow $2,500 from a friend and promise to pay back 26.55 in 6 months. What simple interest rate will you pay? All right, so you borrow 2,500, so that's your principal. The rate is what we're trying to find out, so that's the unknown piece. That's why there are question marks there. Time is 6 months, 6 over 12 or 1/2 will be what you plug into your formula. And then it says after 6 months, you're gonna pay 26.55. So that's actually your future value. So this time they give you the future value. We take the same formula and plug in the values accordingly. All right. So now we need to solve for R. I went ahead and converted at 1.2 to just 0.5 because I'm about to distribute 2,500. 2,500 times 1 is 2,500. 2,500 times 0.5 is 1,250. So I have 26.55 equal to 2,500 plus 1,250 R. Solving for R, remember that's what we're doing here. So we'll subtract 2,500 from both sides. Then divide both sides by 1,250 to get R by itself. So R is equal to 0.124 or 12.4%. And so you just have to make sure you answer according to what Math Lab is asking of you. If they want the percentage, 12.4%, or if they're okay with the decimal 0.124. Questions, questions, questions. All right, I believe, yep. So that's it for 8.3. We're not going to go any further. That's where I'll stop in my last class. So I'll try to keep everybody together. So now what we have as far as chapter 8 is concerned, just 8.4. And then we'll be looking to get into chapter 9. Yeah, that's 9.1, 9.2, and 9.3. So, yep. So any questions before we close out? Everybody good? Everybody straight? Everybody on Zoom? All right. So if you guys are good, I'm good. Have a great weekend. Be safe. Enjoy the Super Bowl and all the good stuff's gonna happen this weekend. And I will see you on Tuesday.